Now let us start the chapter 4. The runoff. Runoff is nothing. It is the portion of the precipitated water that enters into the river or stream. That is the runoff. And that runoff may be either the water flow towards the river or stream from the overland flow or from the top surface of the soil from the top of the earth surface towards the river or from the underground soil layer by the infiltrated water that can be moved horizontal towards the river through the soil particles. So this is the runoff. That is, it is the portion of the precipitated water that reaches the river or stream through the surface or subsurface flow. The water that flows towards the stream, river by overland flow, that is surface flow, is very fast and also called direct runoff. Whereas the horizontal movement of water that is through runoff through the underground soil is very slow to reach the river and stream, and also called the delay flow, also known as the base flow. Base flow provides the water to the river as a delay flow. That is sometimes the base flow. That means the flow of water that reaches to the river or stream is very slow. That is when the snow is melt, and after melting the snow, that water is had to reach the nearby river. Okay, and that the process of melting of snow is very slow, and that water reaching the nearby river or stream will be delayed. That is also considered as the base flow. Okay, but the fast flow, that is the, if there is heavy rainfall, then water that is flown from the top surface of the soil towards the river or stream will be very fast to get into the river, nearby river, by the overland flow is very fast. That is called the surface runoff. And the runoff is the portion of surface runoff as well as the subsurface runoff. Both of them are considered as the runoff, but basically the flood in the river is basically due to the subsurface, due to the surface runoff only, because subsurface runoff only maintains the low level flow towards the river during the winter season. Okay, now surface runoff, the precipitated portion of water that takes its way towards the river or stream through the surface flow, that is overland flow, is called surface runoff. Surface runoff provides the flash flood discharge to the river. Flash flood or fast discharge to the river. If the runoff is high, then the discharge will definitely be high, because the depth of flow will be increases, velocity of flow also increases, hence the discharge also increases. Okay, and this is the surface runoff. Now the drainage basin and its quantitative characteristics. What is the drainage basin? The drainage basin are the catchment area which provides the water towards the certain river. That is, precipitated water ultimately flows towards the small rivers or stream near them. Many streams and the rivers, small rivers again feed water to the big rivers. Generally, area is divided into different basins and catchment that is covered by big rivers. Generally, area is divided into different basins and the catchment that is covered by big rivers. That is called the drainage basin or the catchment area. Okay. Now in Nepal, the major basins are Kosi, Narayani, Bagmati, Karnali, Mahakali, Vaisrapti, Kankai, Kamala. These are the these are the important major basins of Nepal. You may have the Gandaki basin. That is Gandaki basin is up to the Magdi district. That is the river that is called the Gandaki basin. And from Kaski district or towards the to the Chiton district, all the tributaries of the Gandaki river are considered as the Narayani basin. Okay, Seti river, Badi Gandaki, Kali Gandaki, Tirisudi, These all Marsang, all rivers are the Narani basin. So and they are the tributaries of the Narani basin, and that is called Narayan basin. And Bagmati river, that is flown towards the eastern side of the Nepal, from the Kathmandu Valley to the zone of the Janakpur side. That is Bagmati river, that is being very large. After reaching the Sarlai district, uh, this Bhagwati river is getting very big, and that basin is called Bhagwati basin. And the Karnali basin, this is for the western part of Nepal, Mahakali, western part of the Nepal, West Rapti, this is to the Dang district, okay. Kankai, this is the eastern part of Nepal, and Kamal are also in the eastern part of the Nepal. These are the major rivers, and their basins are considered. Okay, the basin characteristics are generally determined by its geology, geomorphology, area slope, and drainage basin dynamics. These are the basic characteristics of the drainage basin. The drainage basin has the different character. Their geology is different. Geology is different means the type of the land formation, that is of the type of soil, rock, strata, and the rock may have the different fault and folds and between different cracks there. So the this formation of the soil layers and the rock structure is related to the geology. If there is the rocky strata over the surface, then that rocky strata helps not to allow infiltration into the underground soil, because that will obstruct the underground flow, seepage flow. So hence the runoff water will be more at the surface runoff towards the river if the geology of the rocky strata. If there is porous soil, there is cracks in the strata, then chance of loss of water into the underground soil takes place. And these are the geology. And the basins are mainly considered as safe. According to the shape of the basin, the basin can be either that may be fan-shaped basin, or that may be fawn-shaped basin. The fan-shaped basin is very large and very broad, but the fawn-shaped basin is very small, and it is of lengthy length. Okay, comparison to the width. So there the fawn-shaped basin has the chance of having the unland flow, that is the flow from the runoff from the surface, is very predominant in the Fansed basin, whereas in the Hansed basin there is a chance of channel flow, because the main stream or main river has the different tributaries that is reaching towards it, and all the tributaries are similar nature and are of equal length, so that all the water that is reaching from the highest part of the area to the main stream is generally reaches as a same more and less at the same time. So that the peak flow for the Fancy basin will be slow rate at the slow rate, while at the peak flow occurs to the Fancy basin is very fast, and it's at the because the tributaries are small, and they can feed water into the main stream or river, or from the island flow, from the ground surface flow towards the river with the very small distance, there the peak flow can be occurred at a very short duration of the time before after the precipitation in the Fancy basin. So the discharge of the Fancy basin is very large, because the area is very poor, and the rainwater that is collected from the whole area that enters into the main stream is that will be a greater amount quantity, and the discharge of the river will be very high in comparison to the pond shape basin. These are the concept shape of the basin. For the fan shape catchment, which is broad and spread so that all the tributaries are approximately of same size, providing greater runoff, because peak flood from the tributary is likely to reach the main stream or river approximately at the same time. For the case of Hornsey Basin catchment, which is small and elongated, all the tributaries have the different length and meets the main river at regular intervals. They receive water from the small area in one hand, and in another the time of concentration travel water from the farthest area to the outlet of the catchment will be high, hence the reduce the occurrence of the peak flood intensity in the comparison to the fan shape catchment. Now the size of the basin, for the small size basin, overland flow is more predominant, whereas the large basin channel flow is predominant, providing constant minimum flow than small basin. Now slope of the catchment, if the catchment has the steep slope, the chance of flowing water from the surface to the stream will be high, because due to the steep slope of the terrain, the chance of drainage of water from the upstream side to downstream will be very fast. So that the steep slope for small basin produce the high peaks, which controls the velocity of the flow. If the slope is very steep, then the velocity of flow will be high. If the slope is gentle, the flow velocity will be mild. If the if the ground is level, then the velocity of flow will be very small. So that it is related to the overland flow infiltration capacity. If the slope is moderate, then the chance of the flow will be the water that is deposited on the surface of the water remains for longer time on the earth surface, so that it may be chance to infiltrate into the underground soil. So the infiltration capacity may be increased for the increases due to the small slope ground with comparison to the steep ground. And the time of concentration of the rainfall, that is time of concentration of rainfall means the travel time of the water from the farthest part of the area to enter into the main river or the outlet point of the catchment area, and that is that time is called the time of concentration. If the slope is gentle, then the water to reach from the farthest point to that the river outlet point or river inlet point will be long. So the time of if the time of concentration will long, the chance of loss of water from the traveling forces may occur. So the runoff will be less. Okay. If the time of concentration is less, then the runoff will be high. According to the slope, and the slope also helps to related to the what type of flow is predominant according to the slope of the basin. Whether the flow will be overland flow, whether the flow will be infiltrated into the soil, whether the soil's infiltration capacity will be increased or decreased, whether the time of concentration will be high or less, which is determined by the slope of the catchment. Now elevation. Similarly, the elevation means the height of the catchment area. We can see that when the altitude of the area increases, then the pressure of that area will be decreased. The pressure is high in the Tara area than in the mountainous region, and as the altitude increases, and the temperature also decreases. Pressure decreases, temperature decreases, so that the climate will be different. The climate will be cold in the higher altitude zone, so that when water falls in that area, when there is a precipitation occurs in that area, there may be chance of falling of snowfall or the icefall. Okay. At that time, that snowfall or ice, that is water is in terms of the ice, that have to be melt before it flowing. Okay, the time of melting, during the melting process, the melting is very slow. When the water melts, then that water may be sucked by the soil, so the chance of having the surface runoff will be very less in comparison to the um, uh, low elevated area. Okay, so the elevation helps. It is related to the effect of evaporation and precipitation and the effect of the snow is here. So that accordingly, which if the precipitation occurs in the form of liquid, then chance of flowing of water from the surface is very high. If the precipitation is in the form of snow or ice, then chance of flowing water from the surface flow towards the river is uh, very low, and there may be chance of having infiltration loss. Okay, and the evaporation, because the temperature is very cold in the higher altitude area, and the evaporation loss is very low in comparison to the low elevated area. Okay, this is the elevation. And drainage density is nothing, it is a ratio of total length of the channel to the total area of drainage. If the area of the catchment is one, and there are so much rivers to drain water into the outlet of the drainage area, then the total length of the river is divided by total area of the catchment. That is called the drainage density. Drainage density means the provision of tributaries and different stream or channels to carry water from the catchment area to the nearby main river. That is the different types of rivers and their length. The wave of the wave WB wave, the wave of the channels having the greater number of the streams or rivers or tributaries provided in their drainage area, has the drainage density higher drainage density. That higher drainage density reflects reflects that the chance of flowing water towards the main river from such a drainage or such a tributaries is very chance of carrying water from the such a tributary to the main river is very is help they help to carrying water to the main river through their channel so chance of having infiltration loss and other losses will be low, so the surface runoff will be high. So there the main river or main basin river can get the can feed water by all these channels. That is the if the drainage density is high, then all these channels can take water, can deliver water to the main river basin through channel flow. Okay, drainage density higher, the drainage density faster will be the runoff, and the runoff discharge will be high. Okay, the ratio of total length of the channel to the total drainage area. Higher the drainage density, higher and faster runoff response can be occurred, and vice versa. Now, land use pattern. This is also the characteristic of the drainage area. If the land is used for the cultivation purpose, if the land is used for cultivation purpose, means that land is timely dug and timely plow by for the purpose of cultivation, so that the soil topsoil of the area is loose due to the timely cultivation process, so that the chance of infiltration of water from such area is predominant, and the loss of water into the underground soil will definitely reduce the runoff, surface runoff. Okay, cultivated land low runoff, and for the barren land where there is no cultivation is done, for the barren area that may be high runoff. because the soil particles is being compacted by the rainwater, and there is no vegetation cover in the barren land, so that these barren lands may have the less infiltration rate, and so that the runoff rate will be high. That is, surface rate will be high in the barren area in comparison to the cultivated land. This is the land use pattern. And the soil type. According to the type of the soil, condition of the permeability of the soil, whether the soil is permeable or impermeable, what are the soil that is highly porous or highly dry, or that has the voids containing much voids, that the infiltration rate will be high, so that water holding capacity of the soil also determines the surface runoff, determines the whether the soil is able to hold the water or not. If the soil is very fine, then it cannot absorb too much water, because the chance of absorbing water from by the fine grain soil is very less in comparison to the coarse grain soil. So the chance of surface runoff is high for the fine grain soil than the coarse soil. This is the soil condition and orientation of the basin. What is the orientation of the basin? This means where is the basin, how the basin is situated. If the basin is situated at the leeward side of the area, that is, if the basin is situated at the leeward side of the area, means that is the backward direction of the flow of the wind direction. That is, and in that case, the chance of having rainfall will be low. For the leeward side, the chance of having rainfall will be low. So the such catchment does not get a sufficient amount of the this water, that is runoff water. So the runoff will be less for the catchment that is situated at the leeward side. For the catchment which is situated at the windward side, then that the windward side catchment has the has the has much more precipitation, so that the if the precipitation is more, ultimately the runoff will also be more. So the for the windward side catchment, the runoff value will be high than the leeward side catchment. In this way, you can explain the these are the basin characteristics that can affect the that can affect the surface runoff. Okay, these are the characteristics. You may be asked in the question, what are the drainage basin, what are its characteristics, how they affect the surface runoff. You may be asked in this way, what are the factors affecting the surface runoff? The factors affecting the surface runoff is basically divided into two parts. One is climatic factor and the another is physiological factor. These are the drainage basin characteristics are the physiological factor. These are all are the physiological factor. Shape, this are the slope of the catchment, elevation, drainage density, land use, soil type, orientation of the basin, etc. Are all of these are the physiological factors. Okay, and for the climatic factor, basin characteristics and the physiological factor are the same thing that we have already discussed in the characteristics of the basin already, so it is not explained here. And for the climatic factor is the precipitation characteristics, that is the duration of the rainfall, type of rainfall, intensity of rainfall, that is the magnitude of the rainfall distribution, coverage of the rainfall, initial losses, interception and depression storage, as well as evaporation and the transpiration. These all are the climatic factors. If the precipitation characteristics are duration of the rainfall, if rainfall is occur for the longer duration, then chance of having surface runoff will be high, because the soil already dry will be saturated, fully saturated, and the saturated soil does not absorb much water into the soil, so that infiltration loss will be reduced, and hence the water will flow from the top of the soil towards the stream, that the surface runoff will be increases due to the duration of the flow. For the longer duration of the rainfall, the surface runoff will be ultimately high. And type of the rainfall is generally the rainfall or precipitation is any form. The rainfall also can be classified as the heavy rainfall, moderate rainfall, and the low rainfall, or drizzle may be there. Drizzle may be there in the form of smaller rain droplet, which is less than 0.5 mm, and that the precipitation means if there is heavy rainfall, then heavy rainfall will provide the sufficient amount of the surface runoff, then the moderate and the less rainfall. Okay, you can do in this way. Intensity of the rainfall, if the intensity of rainfall is very high, then the chance of compacting the topsoil pores by the raindrop may be high. That is, the top layer of the soil will be compacted due to the rainwater. Okay, so that the infiltration of the water into the underground soil is will be less, because the soil pores, soil particles on the surface of the land is compacted by hitting it by the rain droplet. Okay, that time the upper layer of the soil will get compacted, and so the compacted soil does not allow much more water to infiltrate in it, so the hence chance of having the surface runoff will be high if there is a high intensity of rainfall. And the magnitude of rainfall, that is, the if the depth of rainfall is very high, that is intensity high, then depth of rainfall also very high. You can use, if the magnitude is very high, chance of flowing water to the stream will be high. Okay, now rainfall distribution, if rainfall is occurring within the catchment area, that is covering the whole catchment area, if the rainfall is occurred, then chance of flowing water to the catchment basins, main river, will be very high from all the parts of the area. If it is confined to the coverage of rainfall to the certain small area, then that small area's water will only flow into the river, so that the discharge of the river will not be increases as rainfall occurs for the whole area that is covered by the rainfall. Okay, if the rainfall is occurred for the larger area, then the larger area receives the amount, precipitated amount, and that is of a larger value, greater value, and that is prone towards the river, with the river discharge will be high, that is runoff will be high. Okay, and initial losses, if you consider the initial losses, if the soil is very dry, if there are the depression storage in the area, lots of depression storage, so that these depression storage or intersection loss may use the water before it start flowing towards the river. First of all, the precipitated water fulfill the demand of interception and the depression storage. After fulfilling the demand of interception and the filling the depression spots of the terrain, then only the water starts flowing towards the river. So if initial losses are very high in is very high in amount, and then the chance of having surface runoff will be less. Okay, and the evaporation and the transpiration ultimately helps to loss the precipitated water towards the atmosphere again. That is the water that is fallen from the atmosphere to the earth surface, that is again escaped out into the atmosphere by the process of evaporation and transpiration. So the chance of flowing water will be low. If the evaporation and transpiration is high, then chance of flowing water will be low. That is, surface runoff will be reduced. Okay, these are the terms. You can, in this way you can explain the factors affecting runoff. One is physiological factors, and another one is climatic factor. You can describe on the basis of these two factors the factors affecting runoff. The physiological factors are the basic characteristics which have been already discussed. Yeah, okay, these are the drainage basin and its characteristics are the basin characteristics, and the another one is climatic factor related to the precipitation and the initial losses and the evaporation and the transpiration. Okay, these all are the factors affecting runoff, which is very important in terms of the examination. It may be asked in the final examination at the theoretical part. Okay. Now, rainfall runoff relation or rainfall runoff correlation. If for a catchment or for a basin or for a river, if we develop the relation between the rainfall and runoff, then for any value of runoff, and the for any value of runoff, the we can predict the rainfall amount, or for any value of rainfall amount we can predict the runoff amount. That's why this is the relationship between the rainfall and the runoff. Okay, and the graph is plotted. The rainfall is plotted, runoff is plotted in y-axis, and rainfall is plotted in x-axis, and the curve is obtained. With the help of that curve, the equation is derived. If the curve, the generally for the small basin, whose area is less than 500 square kilometer, that basin is considered as the small basin. And for the small basin, the linear relationship between the rainfall and the runoff is considered. That is, it can be runoff is equal to AAP plus B. This is the linear equation. Y is equal to mx plus C, similar to the linear equation, straight line equation. This is the linear relationship between the runoff and the resulting rainfall. Okay, this equation can be established, and for solving the parameters of A and B, you can use the least square method, as in the previous case of the Horton's equation. We have derived the Horton's equation, and that equation is converted into the equation of the straight line, and the parameters of the M, parameter of the C are calculated in the Horton's equation. With the help of that, the value of K is determined. The value of absorbance FC is determined with the help of that. So, and the equation is derived, and the Horton's equation is derived to the simpler form. And knowing the some value of the time, the infiltration capacity of rate is calculated using that equation. Similarly, if you know the parameters A and B, then relationship between R and P can be established by linear relationship for the small drainage basin having the area of 500 less than 500 square kilometer. Okay, and where A and P are coefficient, you can see at that the relationship between the rainfall and the runoff is very complex and is mainly affected by the basin characteristics as well as the precipitation characteristics. However, with the known values of the precipitation and the resulting runoff can be plotted in y-axis and the x-axis representatively, and following and drawing the best fit line by accepting the result. If the correlation coefficient is nearly to the unity, that is generally more than 0.60, and that is accepted as a good correlation between the rainfall and the runoff. Okay. For the small basin, linear relationship can be established where R is given by R is equal to AP plus B, where P and R are the precipitation and R is the runoff, and A and B are the equation of the coefficient of the linear equation of the runoff and rainfall relation. This is for the A and B. This equation is similar to the equation of the straight line. This is for this y is equal to r, A is equal to m, P is equal to x, and B is equal to c. Y is equal to mx plus c. You can see here that. And for this equation, we can find the value of parameters A and B by using the least square method. For A, n summation rp minus summation r into summation p divided by n summation p square minus summation p whole square, because r is equal to y, p is equal to x. Similar to that equation, n is equal to summation xy minus summation x summation y divided n summation x square minus summation x whole square. This equation is same as we did in the Horton's equation. Okay, you can find the value of A using this equation, and the parameter B can be calculated after finding the value of A. After finding the value of A, B is calculated as summation r minus A summation p divided by n. N is the number of data provided for establishing this equation. Okay. Now number of observation or data provided is n, and you can establish you can find the value of A and B. After putting the value of A and B, the R is equal to something P plus B. Okay. If you know the value of R, P can be calculated. If you know the value of P, R can be calculated. This is the linear regression equation. And for finding the correlation coefficient, you can use the equation as n summation rp minus summation r summation p divided by under root n summation p square minus summation p whole square into n summation r square minus summation r whole square. Both of them are in under root. Okay. If the value of r lies between r is greater than 0.60, the value of r lies between 0 to 1. If the r value is greater than 0.60, then the relationship between r is equal to ap plus beta. This equation will provide the good relationship between the runoff and the precipitation. That is generally denoted by the coefficient of runoff. If the coefficient is near to 1, it is very good. If the coefficient is less than 0.5 or less than 6 and it is near to the 0 value, then that will be bad correlation. That relation does not establish the proper relationship between the resulting runoff and the precipitation. Okay, we can use that. For the large basin, for the second case, for the large basin, the exponential relationship can be established between the r and the p, so that r is given by alpha p power beta. R is given by alpha p power beta. This equation is the exponential equation. This relation can be established for finding the relationship between the runoff and the resulting precipitation. Okay, this equation can be established. This equation can be converted into the straight line equation by taking the log on both sides. You can take log log, or you can take ln natural log also. I have taken the natural log here. Ln r is equal to ln alpha p power beta. If we ln a into ln b, ln a into b, this equation is can be written as ln r is equal to beta ln p plus ln alpha. Okay, this equation can be established in this way. And this equation, if you compare this equation, y is equal to mx plus c, then y is equal to ln r, m is equal to beta, x is equal to ln p, and the c is equal to ln alpha. If the compare this equation 1 with this equation of straight line, then y is equal to ln r, m is equal to beta, x is equal to ln p, and c is equal to ln alpha. Okay. After finding this equation is similar to the equation of the straight line. So the using the least square method, the value of beta can be calculated as beta is equal to m is equal to beta. So the beta is equal to n summation xy minus summation x summation y divided by n summation x square minus summation x whole square, as in the case of the Horton's equation. We did it in this way. Okay. you can find the value of beta. Okay. Now, after finding the value of beta, the value of constant C can be calculated as summation y minus beta summation x divided by n, because beta is equal to m. You can put the value of beta instead of m also. They both of them are same. And after finding the value of m, the C is calculated. But C is ln alpha. C is ln alpha. So C is ln alpha. The alpha will be e power C. The alpha will be, the value of alpha will be e power C. You can take the you can get the value of alpha here. After getting the value of alpha and the beta, the equation will be r alpha times p power beta. The value of alpha and beta are calculated from here. And if you know the value of p, the r can be estimated. If you know the value of r, p can be estimated using this exponential equation for finding the relationship between the r and resulting precipitation p. Okay, in this way we can establish the correlation between the rainfall and the runoff. Okay, this is for the larger basin, the area having more than 500 square kilometer. We use the exponential relationship. The R is the coefficient of runoff correlation can be established by n summation xy minus summation y in summation x divided by under root n summation x square minus summation x whole square into n summation y square minus summation y whole square. These both the terms are under root, and this value is divided by under root this value. You get the value of r. That r lies between 0 to 1. If the value of r is greater than 0.6, it is considered as the good correlation. If the value of r is less than 0.50 and the value is considered as a bad correlation. Okay. This is the how can you establish rainfall runoff relationship? This may be asked in the final question, or you may be asked to find the value of the rainfall with respect to the given runoff, or you can you have to find the value of runoff with respect to the given rainfall value using the rainfall runoff relationship or correlation. Okay, you can do in this way. Now, in 4.4, stream gauging, site selection, type of gauges and the measurement. Stream gauging. Stream gauging means to measure the parameters of the stream flow or river flow is the stream gauging generally. Generally, gauging indicates to find the depth of the flow. Generally, gauging indicates to find the depth of the flow at certain location of the river. Generally, but stream gauging does not only covers the measuring the depth of flow only. It also considers to measure the velocity of the flow. It also considers to measure the discharge of the flow. It also considers to measure the sectional area of the flow. Okay, these all are things are the stream gauging. That for that gauging side we take the stream depth, we take the stream velocity there, we take the stream discharge there, we take the sectional area of the gauging station also measured there. So for stream gauging, the site must be very stable. The site must be stable, straight. There must not be low velocity and the very high velocity. Their site must not be affected by the backwater effect. That site must not be obstructed by the vegetation or plantation or the aquatic woods and plants, or there is no change of there is no erosion of the banks due to the flowing water. There is no deposition of the sand particles or any other riverbed materials along that site. So that site must be free for measurement of the certain parameters of depth, velocity, and the discharge. That can be done. That can be done easily from that site. Okay, that site must be straight. The bank must be stable. The bed must be stable. There is no disturbance by the wild animals or the aquatic animals. There is no there is no either too low velocity or too high velocity. Then that side cannot be disturbed by the backwater effect. Okay, and that side is not disturbed by the wild animals, and there is no excessive vegetation in the site. Okay, the site is accessible. We can go and measure the parameters of the river in that site easily. That site is reachable. Okay, the site must be up to 100 and up to upstream side 100 meter and downstream side 100 meter. The site must be straight, and the site must not be meandering site. Meandering site is not considered there. Okay, and these are the there is no generation of the eddies and the turbulence flow at the place of the measuring site. And these all are the points that should be considered. The gauging site is the particular location of the river from which required depth, velocity, as well as the discharge of the river can be taken timely for the future records. Following points should be considered for the selection of the gauging sites. One, sites should be easily accessible. Okay, and to that site, one people can go and measure the data from that site. The site is accessible for the recorder. Okay, that must be accessible, and the reach of the river should be straight up to 100 meter upstream and 100 meter downstream from the gauging place, having stable banks. Cross sections of the river does not changes according to the season. That is well defined and regular cross section. The cross section must be well defined and regular, means that is not affected by the water. That is the banks and sides. If the bank sides and the bed of the river is not affected by the flowing water, then section will be constant and regular. If there is deposition of the sand or boulder near the site, and if there is chance of erosion of the banks, then the section of the river will be changed. Okay, so for that we must select the stages of the river where there is no chance of having the erosion of the beds and banks. Okay, this is the another point. And the velocity of flow should not be too low or too high. The velocity must be 0.1 to 5 meter per second. At the gauging station, the velocity should not be less than 0.10 meter per second and should not be higher than the 5 meter per second. Okay, this is the condition. The part of the river is the chance of having great fluctuation stage of the river. The gauging site should have the different depth of the river, because the side from where the rise or raise or decrease depth of the river can be taken easily. That may be there is the side where is the greater fluctuation of the river state due to the different flow of the different flow discharge of the river, different velocity of the river. The river water depth must be changed. At that place is suitable for measuring the river parameters. That is the great fluctuation site is considered as the gauging site, and no wild animals activities in the site. That is, the site should not be used by the wild animals for the drinking, bathing, as well as even crossing purpose. If one can go there for measuring the discharge, at that time the wild animal can attack him, or seeing the human being near their territory, then the habitat of the wild animals may be disturbed. In the both cases, one is there will be chance of risks of attacking by the animal, and second is there will be chance of loss of habitat for the wild animals due to the human activities near their site. Okay, so that as far as possible, we should not provide the grazing site near the animal activities area. Okay, now no excessive algal or aquatic weed growth or vegetation or plant growth in the river water that disturb the gazing site. If the underwater plants or algal growth or other plants are grown inside the water, then that may disturb the gazing station for taking the discharge depth and velocity. Okay, as far as possible, and the algal growth and aquatic growth place as well as the vegetation cover area is not considered for the gauging station. Now, no backwater effect at the site due to the construction of hydraulic structure near it. If the hydraulic structure is constructed near the gauging site, then the due to the due to the obstruction of the flow by the hydraulic structure such as dam or well or barrage, and that time the water will be headed up at the gauging station. So that effect is called the backwater effect. So that is called no backwater effect at the site due to the construction of the hydraulic structure near it. The site must be away from the hydraulic structure. That means the site is away from the hydraulic structure of or hydraulic structure, and the site if the hydraulic structure has the backwater current effect, then that current effect should not disturb the measurement of the river parameters. Okay, this is the backwater effect. And not having excessive turbulence and eddies. The eddies means boomerang, and the turbulence, the velocity should be uniform velocity is best for the gauging site. Uniform velocity is best for the gauging site rather than the turbulence flow, and the eddies may disturb the gauging site because the eddies may erode the may erode or may disturb the instrument that is installed near the gauging station. That may disturb the instrument that is installed near the gauging station. So the turbulence flow as well as the formation of eddies is not considered as the good for the gauging site. Okay, these are the points for the criteria for selection of the gauging site. This question is asked several times in the final examination. Now, type of the gauges, and now we are going to study about the type of the gauges. What are the gauges? What are the gauges? Gauges are nothing. These are these are the member. These are the device member or ways to measure the depth of the flow. These are the uh, members, device, or things that is used to measure the depth of the flow. These are all are the gauges. Okay, different types of gauges can be used for measuring the depth of the flow of the river. Staff gauges. Staff gauges are the vertical bars provided with the graduations as the staff. You use the staff for surveying. Okay, in the staff there is the graduation mark as in the scale. There is the graduation, and that staff is inserted into the river, and up to which level the water washes the staff, that level is recorded. That is the depth of flow. That is the depth of flow. You can see here that the staff gauge may be single staff gauge, or that staff gauge may be of multiple staff gauge may be used. If the river is very high and the one staff gauge doesn't measure the depth of flow, then other staff gauges are also inserted accordingly from the bed of the river towards the bank side, as shown in the figure, so that this level of water is the depth of flow. That is the level of the second staff reading is considered here. Second staff reading is considered here. The first staff reading is after the full height of this staff is submerged by the water, and from this level to the water surface level of the second staff reading is measured, and that full height of the first staff gauge and the difference between the first gauge and the second gauge water level is added to find the total depth of the water. Okay, this is the staff gauge. They are the wooden bar or metal bar provided with the graduation. The level at which the river water was the graduation will be the depth of the flow of that river at that time of measurement. This reading should be taken manually. For the staff gauge, the reading is taken manually. Now, wire gauge. This is another type of the measurement for measurement style or technique to measure the depth of the flow. In this measurement, the vertical bar is not used. The rope or the cable is used. The rope or cable is provided with the metal disc at its end, and that is inserted into the river bed using the pulley. Okay, the weight of the weight portion of the rope is measured. The weight portion of the rope is measured. That gives the height of the depth of the flow. The weight portion of the rope, that is water weight portion of the rope, is measured along with the metal discs, and that depth gives the depth of flow. This is the wire gauge. The rope or wire is provided with the weight discs attached to it, is lowered into the river towards the bed from the fixed reference point with the help of the pulley arrangement. And the weight portion of the rope with the disc length is measured by tape to know the depth of flow. This is the depth of flow. Okay, you can see here that wire gauge. And the float gauge. The float gauge is this is the automatic type of the recording of the depth of flow. This is provided with the sink well. Sink well is provided here near the river side, so that the float gauge is installed inside the sink, and so that it may not be disturbed by the flood wave of the river. So that it may not be disturbed by the flood wave of the river. The water level of the river and the water level into the sink well is same, and the floating object is the float may be rises up or down according to the change in the stage of the river, change in the river water level. So the accordingly which the this float is balanced by counterbalanced by the weight as seen in the figure. When the float moves up or down, and there is the recording mechanism provided here, that the movement of the float up and down helps the angular movement of the rope and the pulley, which provides the input to the shaft to record the revolving drum by the system. Okay, this is the float gauge. It is the recording type gauge which consists of the float attached with the wire rope is counterbalanced by the weight. Due to the rise or fall in the stage of river, the float moves up or down accordingly. The movement of the rope, angular displacement of pulley provides the input to the shaft to be recorded on the revolving drum. This is the recording type of floating gauge, is recording type of gauge. Now the bubble gauge. This bubble gauge is nothing. It is from the instrument room. There is the pressure, air is blown towards the bed of the river. The air is maybe of carbon dioxide or nitrogen. That air is passed from the small pipe to the base of the river, and that river water is pressed by the gas outlet is pressed by the water, and that pressure exerted by the water to the inlet point of the pipe is recorded into the instrument room by the manometer. That pressure manometer is installed there, and with the help of that pressure manometer, the pressure of the water is measured there. And by knowing the pressure of the water exerted, the equation can be used as pressure is equal to gamma H. Gamma is the weight density of the water. Then knowing the weight density of the water, the height of the flow will be as equal to pressure by gamma. This relation can be used to find the depth of flow. Okay, this is the bubble gauge or pressure gauge. It consists of a small tube which is placed at the bed level of the river, and the compressed air of carbon dioxide and nitrogen is continuously bubbled out with the pressure, which is measured by the manometer in the record house, and the calculation of the pressure is given by P is equal to gamma S, and gamma is the density of the water, P is the pressure of the pressure that is recorded in the manometer, and that pressure is not. After knowing the pressure, knowing the density of water, the depth of water can be calculated by using this formula. S is equal to P by gamma. Okay, this is the bubble gauge. These are the different types of gauge. Four types of gauge are discussed here. That is strap gauge, that is wire gauge, float gauge, and the pipe gauge or pressure gauge. Okay, bubble gauge. Now, 4.5 the stream flow measurement. How can you measure the velocity of the flow? How can you measure the discharge of the flow? This is the stream flow measurement, and the flow is measured in terms of the discharge. That is, you can use the velocity area method. Discharge is equal to area into velocity of flow. Area of the cross sectional area of the flow into velocity of the flow. You can find, if you know the velocity and the area, you can find the discharge of flow. Okay. For finding the velocity, here they, according to the course of study, the current meter, float, and the velocity rod is used here. Current meter is the device, and floats and the velocity rod is used here. I am doing first floats, velocity rod, as well as the current meter as the last. Okay. Now measurement of flow velocity. Flow velocity can be measured by different techniques. Other techniques can also be done to measure the velocity. By using the dilution technique, also you can measure the velocity. Also you can measure the velocity, or similarly, if you want to measure the discharge of the flow, you can measure other hydraulic structures. Using the hydraulic structures also we can measure the discharge by constructing the rectangular wire or notches, or triangular wire or notches can also be used, and with the help of that wire or notches we can measure the depth of water above the crest of the wire or notches, and using the rectangular wire formula you can find the discharge passing through the wire. That is the discharge of the flow. Okay, you can do in this way also, but according to the syllabus, the current meter, float, and the velocity rod is mentioned here. I have done with this. The float means the floating object. That floating object may be used to flow from one section to another section, and during that flow of float from one section to another section, the time is recorded, and the distance between the section 1 to section 2 is measured, and the velocity of flow is calculated by using the formula V measured is equal to distance by time of travel of the float from section 1 to section 2. You can find the distance by time is equal to velocity of flow. Okay, and this is the float method. This is the simple method. The floating object may be any type of object you can use, such as the orange, apple, wood, cork, silver. May be used for measuring the discharge, for measuring the velocity of the flow. Floating objects such as wooden piece, cork, apple, silver, etc. can be used to measure the velocity of flow of the river or stream. For the surface floats, consider the figure. You can consider the figure. There is section 1 and section 2. This is the plan. The floating object, this is the ball. This is the ball, this is the orange. Is float from section 1 to section 2. The flow, when the float is flown from section 1, the stopwatch is on, and when the float reaches the section 2, stopwatch will be off, and the time taken by flow from section 1 to section 2 is calculated, and the distance between the section 1 and section 2 is measured by using the tape. These two sections are separated at a distance L meter apart. You can measure the sections from the by using the tape. You know the length of the length between the two sections, and you know the time of travel of the float from one section to another using the stopwatch. Then you can find the velocity of flow by total length between the section divided by the time of flow of float from section 1 to section 2. Then the velocity of flow is measured. This is the measured velocity. For the actual velocity or average velocity of flow, this measured velocity is multiplied by the coefficient of velocity. The coefficient of velocity may be taken as 0.85 to 0.95. Now measured velocity is equal to L by T. When T is equal to 0, here T is equal to T to travel this. So total time will be T minus 0 equals to T second. And the length of between the section is L meter. Velocity will be distance by time. And distance is L and non. And time of travel is measured here T. Knowing this, the measured velocity is here. Velocity is measured. This is not the actual velocity. This is not the actual velocity or average velocity of flow. The average velocity of flow is calculated by multiplying this measured velocity by coefficient of velocity. The coefficient of velocity may be taken as 0.85 to 0.95. Okay. In this way, you can measure the velocity by using the surface plot. This is the surface plot. Okay. Now using the velocity rod. Velocity rod or subsurface plot is same thing. In the surface plot, the flowing object is flown from the top surface of the water. But for the subsurface plot or velocity rod, and the floating object is flown from the flown inside the water. Is flown inside the water, not from the surface of the water. That is, there is the weight is counterweight is provided to make the float to flow inside the water. Okay, that flow can be provided at the 0.6 depth of flow. That is, if the depth of river is d meter, then the flow that subsurface float is flown at the depth of 0.6 times d depth from the top of the surface. That is called the single point method. And similarly, the when the float is flown from the one section to the another section, and the stopwatch is taken for calculating the time of travel, and the distance between two sections is measured, and the measured velocity is taken as the L by T. That is traveled by the subsurface float, not the surface float, subsurface float. This velocity will be the actual velocity. This velocity has not to be multiplied by the coefficient of velocity, because float is not flown from the surface. It is flown inside the water towards from the one section to the another section. That's why no need of multiplying with the coefficient of velocity. Okay. For single point method, you can add the floating object is flown from underwater in between the sections. Velocity rod are the straight wooden or hollow tubes of tin having diameter of 25 to 50 mm, and counterweight is provided to keep them underwater vertically, so that the small portion of the length of the tube can be remained above the water surface during running underwater. Okay. Now for this, the measurement can be done in two ways: single point method and the double point method. In the single point method, the floating object, that is the velocity rod or subsurface float, is flown at the 0.6 times the depth of the flow from the top surface of the water, and the velocity is measured. The velocity is measured 0.6 depth will be average velocity, which is given by length by time of travel of the subsurface float. Okay, and this does not no need of multiplying velocity coefficient to get the average velocity of flow. This is the this measured velocity will be the actual velocity of the flow. Now, for the double point method, this velocity rod is flown from the 0.2 times depth and from the 0.8 times depth. The velocity for the 0.2 times depth is calculated, and the velocity for 0.8 times depth also calculated in the similar manner, and the average velocity is taken as the velocity 0.2 depth plus velocity 0.8 depth divided by 2, which gives the measured velocity. That measured velocity will be the actual velocity of the flow or average velocity of the flow. Okay. For single point, 0.6 times depth is considered. For double point, 0.2 depth as well as 0.8 times depth of flow is considered. At that level, the subsurface float is flown. This is the double point method. Now current meter.
Hello.
Similar. Hello.
Sir, time vaishakata.
Okay. This much for today. We will do from current meter in the next period. Thank you very much. I will take your attendance. 33 people are present. First of all, I want to download the attendance. Okay. Let me stop recording.